Welcome, ladies and gentlemen. This is Mark Anderson for Kellogg Community College, and this is our last video of talking about solving systems of equations that are nonlinear. Here we have two quadratics, and we're going to see where the quadratics intersect and solve for that using algebra. Though you can kind of see right away that there's a picture of it. And the picture won't be there for your test or homework, but you can kind of see that based on the picture, there are two intersections. And we're going to find these using algebra. So the picture is there just to kind of give us some help in finding these. And in the other videos, we looked at substitution. Substitution is when you can easily isolate one variable. We've also looked at elimination, and that's when the powers lined up between the two different variables. Now this one is going to be the transitive property. The transitive property is pretty straightforward. You know, if A is equal to B, and then if B is equal to C, then A is equal to C. So it basically just takes this connecting equality and just kind of cuts to the end there. A is equal to B, B is equal to C, then A is equal to C. Well, in this case, Y is equal to this and Y is equal to this. Therefore, the two trinomials have to be equal to each other using the transitive property. It's also like a law of syllogism, another way to look at that. So there you go. So there's your Y is equal to that, Y is equal to that trinomial. So the two trinomials are equal to each other. We are now going to subtract the entire right side from itself, or do its opposite, and then do that to the left side to balance the equation. And we will then have all of this simplify to 0. Then what we have on this side is x squared, because 2x squared minus 1x squared is x squared. This is going to be negative 1x, and this is going to be negative 6. And then we will solve for x. And we'll solve for x using factoring, because it's pretty easy to factor this easy trinomial. Two numbers to make negative 6 and add to make negative 1. That is going to be negative 3 and positive 2. Now, if I have my x minus 3 equal to 0, I'm then going to add 3 to both sides. So x is equal to 3. And to do this side mentally, if I put x plus 2 equals 0 and subtract 2 from both sides, I would get x is equal to negative 2. So these are my two x values. So now what I have to do is I have to substitute these back into one of these two equations to figure out what my y value is. So I'm going to take this idea of x is equal to 3, and I'm going to plug that into the bottom equation. Now the reason why I want to plug it into the bottom equation, because it has fewer negatives. And we, as humans, usually make more mistakes with negatives than we do positives. So I will now plug the 3 in for every instance of x. So now I've got 3 squared minus 2 times 3 plus 5. So that's 9 minus 6 plus 5. And 9 minus 6 plus 5 is a total of 8. So my answer is 3, 8, which is this, excuse me, this point right here. So 3, 8 is one of my two places where these intersect. So for my last part of this problem, I am now going to move that negative 2 to the bottom equation and see what that gives me. So negative 2 quantity squared minus 2 times negative 2 plus 5. This is 4 plus 4 plus 5, or 8 plus 5, which is a total of 13. So if I plugged in my x of negative 2, and I got an answer of 13, there is my other intersecting point, which happens to be right there. So you can see in this problem that we got our two answers for these two quadratics, and we did so using the transitive property. You could have used other properties as well, but this was by far the quickest. Well, thank you for watching the third part of these 3 videos, and again, if you're looking for the other 2, we were solving nonlinear systems of equations using elimination, and another one using substitution. Thanks for watching.